Hello my dear student, welcome to new session of motion in straight line. It's your 11th lecture. It's a long journey which will complete with motion in straight line. Now we'll reach to last topic of motion in straight line, which is just nothing but related to graph. So write down my dear student, introduction to graph. First of all, we'll discuss what basically graph is, how we'll make graph, and what are the processes, what are the variations of graph. Because graph is just not making a diagram, we have y-axis and x-axis and draw a line. Graph is, my dear student, very important, and with graph we'll introduce lots of things, we'll understand lots of concept related to kinematics. So I hope you all understand each and every concept till now. Up to 10 class you are up to dated, and it's our 11th class. So let's start making graph. So first thing is introduction of graph. See my dear student, for making any graph, I'll write here, for making any graph, for making any graph. See, 2 or 3 things are required for making a graph. See, if I'll say you draw a graph, it's incomplete statement, my dear student. If I'm saying draw a graph, it's nothing symbolized, because for making graph we need something. So that something is basically equation, for which equation you are making graph. Because every graph represents a mathematical expression, or we can say mathematical equation. Remember this thing, my dear student. Graph is basically a picture of any mathematical expression. So very first thing which required for making a graph is its mathematical expression. So I'll write here, first thing which we need for making graph is mathematical expression, or we can say mathematical equation. So remember, my dear student, for making graph, the very first thing what you need is mathematical expression, or we can say mathematical equation. I hope this must be clear for you. See, any graph can carry a mathematical expression, because graph is nothing but a picture of any mathematical expression. So if you wish to make a graph, then at least you need a mathematical expression. So for making graph, first thing is mathematical expression, or we can say mathematical equation. I am using some of the standard equations. See my dear student, this class is related to equation of trajectory, which we already discussed. See, let's suppose we have a straight line like this. We know that straight line carry a mathematical equation, and mathematical equation of straight line is y is equals to mx plus c. So this mathematical equation represents a straight line, my dear student. Basically, if there is an equation written in form of y is equals to mx plus c, then remember, if I am saying that, let's suppose a particle is moving by formation of, or we can say, let's suppose a particle is moving by following a equation y is equals to mx plus c. Then you will click on your mind that okay, y is equals to mx plus c is nothing but equation of straight line. So if any particle is moving in such a manner that it follow a equation which is y is equals to mx plus c, then we'll say okay, the particle is moving in straight line. Similarly, let's suppose if I'll say a particle is moving in such a manner that it follow a equation x square plus y square is equals to a square. So if I am saying that let a particle is moving in such a manner that it follow the mathematical equation x square plus y square is equals to a square, it means the motion of particle must be in circular path, because this equation is nothing but equation of circle. So this is the geometrical identity of circle and this is the mathematical expression of circle. This is the geometrical identity of straight line and this is the mathematical expression of straight line. If there is a straight line, then it's okay, we'll know that this is a straight line. So if I'm saying that let the particle is moving like this, what is the motion of what is the path of particle? So you will say simply, okay sir, the particle is moving in straight line. If I am saying, let's suppose the particle is moving like this, you will say, okay, the geometry is of circle, so particle is moving in a circle. But if geometrical identity is not given and the identity is in equation form, then also you have to comfortable, because my dear student, every graph, see this is a graph, this is a graph, all the geometrical structure is nothing but a graph. If I'll make a straight line, then it also a graph. I'll make a circle, then it is also a graph. So every graph carry a mathematical expression, my dear student. Y is equals to mx plus c is the mathematical expression of straight line. X square plus y square is equals to a square is mathematical expression of circle. X square by a square plus y square by b square is equals to 1. This is the mathematical equation of ellipse, and we know that the structure of ellipse is like this. If I write an equation, let's suppose y square is equals to 4x or x square is equals to 4ay, we know that this equation represents parabola. So we know that parabola is kind of 4 types: right hand, left hand, upper side, lower side parabola, my dear student. So if the geometrical identity is given, then it is okay. But if mathematical expression represents any geometrical identity, then also you have to comfortable on it, because every geometrical identity, every graph, this is the graph of ellipse, this is the graph of parabola, this is the graph of circle, this is the graph of straight line. So every graph represents a equation, a mathematical equation. If you will see, first straight line equation, it is y is equals to mx plus c. If you will see circle equation, it is x square plus y square is equals to a square. If you will see ellipse equation, it is x square by a square plus y square by b square is equals to 1. If you will see equation of parabola, it is y square is equals to 4ax and x square is equals to 4ay. So these are nothing but equation of graph. Equation of graph of straight line, equation of graph of circle, equation of graph of ellipse, equation of graph of parabola. But these equations says a lot. In this equation, lots of things are there to understand. In this lecture, we'll try to understand those things. I'll repeat once again, my dear student, every graph represents a mathematical expression. If you wish to make a graph, then you must know its mathematical expression. Otherwise, you are not capable to make the graph. If I'll say, okay, make a graph, it is incomplete statement, my dear student, because for making graph, we need a mathematical expression. That mathematical expression is expressed in graph. So, for making graph, the very first thing which we required is mathematical expression. So write down your first point. For making any graph, mathematical expression is required. For making any graph, mathematical expression is required. Mathematical expression is required. For making graph, mathematical expression is required. This is the mathematical expression of straight line. This is the mathematical equation of circle. This is the mathematical expression of ellipse. This is the mathematical expression of parabola. So my dear student, first thing that must be clear on your mind, that for making graph, we need a mathematical expression. Now see, every mathematical expression carry two variables. So if you wish to make a graph, then remember my dear student, in mathematical expression, not more than two variables are present. So second thing which we'll introduce now is in mathematical expression, second thing is in mathematical expression, only two variables are required. Only two variables are required. So if any equation carry more than two variable, then you are not capable to make the graph for that expression. Remember this thing. If you wish to make a graph, then you need a mathematical expression, and that expression carry only two variables, not more than two variables. All other terms on that equation are always constant. If any equation carry more than two variable, then we are not capable to make that expression graph. So write down, if any equation, write down in form of note my dear student, if any equation carry more than two variables, if any equation carry more than two variables, then graph is not possible. Then graph is not possible for that equation. Graph is not possible for that equation. So remember this thing, very first thing for making graph required a mathematical expression. Second thing, in mathematical expression only two variables must be present. More than two variables carry equation cannot form any graph my dear student. So remember this thing, equation carry at least and at most two variable. And third thing is, which you have to understand, is any variation in graph. Third important thing for making graph is any variation in graph depends only on constant term. Remember this thing my dear student. If I am saying that y is equals to mx plus c, look at this equation, mx plus c, this is the equation of straight line. In this equation y and x is present, and we know that y and x is nothing but variable. Here two other terms is also present, one is m and other is c. I'll already tell you that m is nothing but slope and c is nothing but y-intercept. So my dear student, this equation carry two variable, so we are capable to make the graph of this equation. But other than two variable, that is x and y, rest term is m and c. So remember this thing my dear student, m is nothing but slope and c is nothing but y-intercept. So slope is constant and y-intercept is constant. So remember this thing, variation in graph only depends on constant term. If graph is varying, then that variation comes through constant term, because variable is not reliable my dear student, and graph is nothing but a structure. So if any term is not constant, any term which changes itself, how we are capable to depend on that term. That's why remember this thing my dear student, that the variation in graph, the changes in graph does not depends on variable term. The structure of graph, or we can say the changes of graph, only depends on constant term. So in this equation, x and y is variable, m and c is constant, m is slope and c is y-intercept. So if we'll vary the graph, if we'll make different graph of straight line, then that graph must be vary on m and c. Remember this thing, that the variation in graph does not depends on constant. The variation of graph will form through the constant terms. So I hope you all understand what things we required for making the graph. Very first thing, for making graph, we need a mathematical expression. Second thing, for making graph, remember my dear student, that the equation carry at least and at most two variable, not more than two variable. And third thing is, the variation in graph depends on constant term. Here I am taking a expression with mathematical equation which represents a straight line. It is y is equals to mx plus c. So you'll see here in this equation x and y is present, and this x and y is nothing but variable. Now other term, that is m and c, I'll already introduce you about m. M is nothing but slope and c is y-intercept. So the variation in graph of straight line must depend on m and c. Remember this thing, the variation in graph must depend on m and c. M is nothing but slope and c is nothing but y-intercept. So if I'll make different graph of straight line, then that different structure is basically depends on m and c. M is slope and c is y-intercept. So I hope you all understand what are the basic requirements of making a graph. First thing, you need a mathematical expression. Second thing, in mathematical expression, x and y, that is variable must be present. And third thing, the changes in graph can depends on the value of constant term. Remember this thing, the changes in graph depends on constant term. Write down in form of note, my dear student, the changes in graph, write down note, the changes in graph, the changes in graph, the changes in graph depends on, the changes in graph depends on the value of, depends on the value of constant term. The changes in graph depends on value of constant term. The changes in graph depends on value of constant term. The changes in graph depends on value of constant term. So I hope you all understand the basic information for making graph. Moving forward, my dear student, let's start making a graph. First thing what I have to make is graph of straight line. So write down different cases of straight line. Different cases of straight line. So first thing, for making graph, I need a expression. So we know that the general equation of straight line, so it is y is equals to mx plus c. Moving forward, my dear student, I'll already tell you that for making graph we need a mathematical expression or equation. So we have a mathematical equation, or we can say expression of straight line. It is y is equals to mx plus c. Moving forward, my dear student, see in this equation we know that for making graph we need at least two variables in any mathematical expression. So in this mathematical expression we have two variable, one is y and other is x. So second thing which prompt that we are able to make the graph for this equation, as we have a equation and this equation two variables are also present in terms of x and y. So I'll write here x and y, two variable is present. Moving forward, rest all terms must be constant. So here other term is m and c. M is constant and c is also constant, my dear student. For graph, m is nothing but slope and c is nothing but y-intercept. And I already tell you, other than x and y, all terms must be constant. So m is constant and c is constant. Now I already tell you that the different conditions of graph, is created, or we can say different conditions of graph is basically depends on constant term. That what is the value of constant? So here our constant is m and c. So I already tell you that the variation in graph depends on constant, depends on value of constant. So x and y is variable, other term m and c is constant. So the variation in graph, the change in structure of graph depends on these two constant term. One is slope and other is y-intercept. So now I'll make the possible things for graph. See, one is m and other is c. M means slope and c means y-intercept. Let us make a graph in which I'll tell you what is the meaning of c and what is the meaning of m. So try to understand, my dear student. We have a graph of straight line, let's suppose. This is a straight line. So we know that any straight line carry a mathematical equation as y is equals to mx plus c. This is our x-axis, this is our y-axis, x and y is variable. Now see, my dear student, this point is called origin, where every value is 0. Now see, this straight line cutted y-axis at this point, this straight line cutted y-axis at this point. So this distance, that is distance between origin and point where straight line cutted y-axis. I am repeating once again, distance between origin and point where straight line cutted y-axis is called y-intercept, and y-intercept is represented by c. Now see, my dear student, this distance is above origin and we know that above origin along y the value is positive, below origin along y the value is negative. Try to understand. Above origin the value of y is positive and below origin along y the value must be negative. And see, my dear student, I'll imagine this x-axis and y-axis to be quadrant system. Then we know that here the angle is 90, here the angle here the angle is 0 degree, here it is 90 degree, and at this point it is 180 degree, here it is 270 degree, and again it is 360 degree. So try to understand, my dear student. This point is called origin and this is the distance. This is the point where straight line cutted y-axis. So this distance along y-axis is called y-intercept. Now see, my dear student, this distance is above origin. So in this situation, c is nothing but carry positive value. Because c is nothing but distance between origin and the point where straight line cutted y-axis. I am repeating once again. C is the distance between origin and the point where straight line cutted y-axis. So this distance basically is above origin, then we will say c is positive. If the straight line is cutted y-axis like this, again, my dear student, this is also a straight line. So equation of straight line, we know that it is mx plus c. Now see, this distance, this is the point where straight line cutted y-axis. So origin to distance is called y-intercept, which is represented by c. In this situation, my dear student, the distance is below origin. This distance, this c distance is below origin. So we will say c is nothing but carry negative value. Remember this thing. If c is positive, it implies straight line cutted y-axis above origin. If c is negative, it implies straight line cutted y-axis below origin. So the value of c is, we can say, sometime the value of c is positive, sometime the value of c is negative. So you have to recall in your mind that if c is positive, it means straight line cutted y-axis above origin. If c is negative, then it implies straight line cutted y-axis below origin. Remember this thing, my dear student. Moving forward. So m is nothing but slope. M is nothing but slope. Now see, my dear student, this straight line is making some angle, let's suppose theta, with x-axis. This straight line is making some angle theta with straight line. In this situation as well, this is our first graph, this is our second graph. Now see, this straight line is also making some angle theta with the x-axis. Remember one thing, if angle is made with x-axis, then that angle is always represent in terms of tan theta. Remember this thing, if any angle is made with x-axis, then that angle is always right in terms of tan theta. So you are seeing here that this straight line is making some angle, let's suppose theta with x-axis. So this theta is nothing but slope, my dear student. This theta is nothing but slope, and in straight line equation, slope is represented by m. So we'll write here as tan theta is equals to m. So this angle, now see my dear student, tan theta. So if I am seeing here, try to understand this thing, this is 0 degree and this is 90 degree. So this angle right now, for graph first, this straight line is making angle some theta, but this angle is less than 90. So we know that if theta is less than 90, then it must lies in first quadrant, and we know that in first quadrant tan theta is positive. So if theta is less than 90, it means angle lies in first quadrant. In that case, tan theta is nothing but carry positive value, and we know that in this equation of straight line, m represents slope means tan theta. So if theta is less than 90, then we'll say m is positive. And now see, this line, this second graph, this straight line is making some angle theta, but if you will feel this angle is greater than 90. Theta is greater than 90. So if theta is greater than 90, then it comes in second quadrant, and we know that in second quadrant tan theta is negative. So if m is negative, my dear student, you have to understand this thing. If m is negative, it implies that the slope is greater than 90. If m is positive, it implies that slope is less than 90. The graph will be, the angle of graph must lies in first quadrant if theta is less than 90, which implies m is positive. And if m is negative, it implies the angle is greater than 90. Greater than 90 means the angle lies in second quadrant, and we know that for second quadrant tan theta is negative. So I hope you all understand the different variations. I'll explain you the variation in value of c and m. C is y-intercept. Y-intercept may be positive, it may be negative. If y-intercept is positive, it implies that straight line cutted y-axis above origin. If C, that is y-intercept, is negative, it implies straight line cutted y-axis below origin. Second thing is, if angle is less than 90, then tan theta is positive. It implies m, which is considered to be slope, is positive. And if theta is greater than 90, that is slope must be negative, because m represents tan theta, and in second quadrant tan theta is negative. So I hope you all understand the variation, how constant can change the nature of graph, or we can say structure of graph. See, in this situation, theta is less than 90 and c is positive. So the structure of straight line is like this. If you are seeing this equation, this graph of straight line, then in this situation theta is greater than 90 and y-intercept is negative. So the straight line nature will be like this. So the structure of graph depends on constant term, depends on value of constant term, my dear student. So I'll make all the possible natures of straight line graph. So I'll rub this. I hope you all understand that how constant can change the structure of graph. We are talking about graph of straight line, and I'll try to make all the possible nature of straight line graph, my dear student. So try to understand. M means slope. There are four possibilities. First possibility is M is positive, C is also positive. Second possibility is M is positive but C be negative. Third possibility is M is negative, C is positive, and fourth possibility, both becomes negative. I'll already tell you that C is nothing but y-intercept. If y-intercept is positive, it implies that straight line cutted y-axis above origin. If C is negative, it implies straight line cutted y-axis below origin. If M is positive, it implies angle must be less than 90. If M is negative, it implies angle must be greater than 90, because M is nothing but slope, and this slope is represented by tan theta. And we know that if angle is less than 90, then it lies on first quadrant, and in first quadrant tan theta is positive. That's why if M, that is slope, is positive, remember my dear student, in that situation angle must be less than 90. If M is negative, it implies that tan theta is negative, and tan theta is negative in second quadrant. So it implies that the slope of graph must be greater than 90. So try to make all the possible cases of this graph. First case, I'll try to make first case. Rest of the case, pause the video and try to make by your own. So case first, M is positive and C is positive. So my dear student, if M is positive, M means tan theta. So if M is positive, it implies theta must be less than 90. And if C is positive, it implies y-intercept is greater than 0, my dear student. Greater than 0. Greater than 0 means above origin. Y-intercept above origin, or we can say C is greater than 0. So I'll make the graph for this condition. See, this is our x-axis, this is our y-axis. In this expression they are saying M is positive. In this condition they are saying M is positive. So M is positive means if this is your 0 degree and this is 90 degree, then the slope must be less than 90. And C is positive. If C is positive, it implies y-intercept must lies above origin. So this is your origin, and the nature of graph must be like this. Now see, this angle is theta and it is represented by M, which is nothing but tan theta. Now see, this angle lies between 0 to 90. So this tan theta becomes positive, and C is also positive, my dear student. So C is also positive. See, in this situation C is positive, and this is nothing but y-intercept. So this is the graph when M is positive and C is positive. M positive means theta is less than 90, and C positive means the y-intercept is above origin. C positive means y-intercept is above origin. So, and the equation of straight line must be y is equals to mx plus c. So this is the first condition graph of straight line. I hope you all understand how to vary the graph. Now moving forward, I'll make second condition graph of straight line. So write down case 2. Write down case 2. We are discussing about case 2. So in case 2, see my dear student, they are saying M is positive and C is negative. So M is positive and C is negative. So if M is positive, then it implies theta must be less than 90. Theta must be less than 90, and C is negative means y-intercept must be below origin. And below origin means negative value, so C must be less than 0 degree, 0. C must be less than 0. Now I'll try to make the graph. See, this is our x-axis, this is our y-axis. In this equation, in this condition, M is positive, my dear student. So if M is positive, it implies theta must be less than 90, and C is negative means y-intercept is below origin. So try to understand, my dear student, this is 0 degree, this is 90 degree. So the graph for this condition must be like this. See, here this point is called origin 0, 0. If you will feel it, then the theta lies between 0 to 90. It implies this tan theta is positive, that is tan theta is nothing but m, so m is positive, and c, that is y intercept, is below origin, so we'll say c is negative. C is negative. So this is the variation, how the graph vary with on constant, on the value of constant. I am expressing that thing. So this equation, this straight line carry equation, y is equals to mx plus c. So for second condition, the nature of graph for straight line is like this. I hope you all are understanding this thing. If c is negative, cut the y-axis below origin. If c is positive, cut the y-axis above origin. If m is positive, it implies theta must be less than 90. If m is negative, theta must be greater than 90, because here theta is represent tan theta. And tan theta in first quadrant is positive, that is from 0 to 90, and in second quadrant it becomes negative, that is greater than 90. Moving forward, we are discussing now third condition. That is, in third condition they are saying m is negative and c is positive. I am making the graph. Third condition is m is negative and c is positive. So if m is negative, it implies, my dear student, if m is negative, it implies that theta must be greater than 90. That is, theta lies on second quadrant, because in second quadrant tan theta becomes negative. And if c is positive, then we will say c is greater than 0, or we can say y intercept is nothing but carry positive value. So I will make the graph for this condition of straight line. Now see, my dear student, this is x, this is y. Here it is 0 degree, here the angle is 90 degree. Now see, m is negative, that means theta is greater than 90, and c is positive, that is y intercept must be above origin. So this is the point called origin, and I'll make the graph for this condition. This point is called origin 0, 0, and c is positive. C is positive means c is greater than 0, that is y intercept is positive and m is negative. Now see, this is the graph for this condition. See, my dear student, you are seeing here that this theta is greater than 90, and this theta is represented by tan theta, and in expression it is m. This point is called origin. This is your y intercept, and y intercept is positive. See, straight line cutted y axis above origin, and theta is greater than 90. That's why m is negative. So if you are seeing that it is 0 degree, this hand is of 90 degree, and this angle is greater than 90. I hope you all understand this expression too. Moving forward, the last condition of straight line, graph of straight line, last condition of graph of straight line, it is fourth condition. In this situation, they are saying m is negative and c is also negative, my dear student. So if m is negative, it implies theta must be greater than 90, because tan theta only gives negative value if it lies in second quadrant. Second, c is negative, it means y intercept below origin, y intercept below origin. And if c is negative, it implies c is less than 0 degree. C is less than 0 degree. C is less than 0. Now I'll make the graph for this condition of straight line. This is y-axis, this is x-axis. See, m is negative. It implies that theta must be greater than 90, and c, that is y intercept, is negative, so below origin. So try to make the graph, my dear student. I hope now you all are capable to make the graph. See, this point is called origin 0, 0. This distance is called y intercept. C, in this situation c is negative because y intercept is below origin. And now see, this angle, you'll feel it, this angle is greater than 90. So if angle is greater than 90, then it implies M and it is tan theta, and this time tan theta is negative. So C is negative, M is negative, M negative means theta is greater than 90. So I hope, and the equation of this straight line is nothing but y is equals to mx plus c. So I hope you all understand how the graph forms, what are the different situations, how the variation, how the graph structure is changes. Remember this thing, my dear student, constant is the term which cannot change, but in graph, remember, the structure of graph changes on the value of constant, not on variable, because variable thing is not reliable, and we are making a structure. Graph is nothing but a structure, simple mathematical structure. So remember this thing, that how we are proceed with graph. So in this class, it's all about straight line. In next class, we'll discuss the variation in graph for equation of parabola, and we'll start making graph related to motion in straight line. For making graph, remember my dear student, the most important expression is, or we can say most important graphical structure is straight line graph. So concentrate on straight line, try to understand each and everything on straight line. I'll make all the possible types of graph of straight line. The variation in graph of straight line depends on M and C. Remember, M is nothing but slope and C is nothing but y-intercept. C may be positive, C may be negative. If C is positive, it implies graph cutted y-axis above origin. If C is negative, it implies graph cutted y-axis below origin. If M is positive, it implies theta is less than 90. If M is negative, it implies theta is greater than 90, because here M represents slope. Slope means tan theta. So I hope you all understand all the basic structure of graph, how I'll changes the graph, how I'll changes the structure of graph on the basis of constant. So in next class, we'll discuss more about graph. So thank you so much, my dear student. Thank you for connecting with us. Stay home, stay safe, take care.